This video is for section 9-7, Products and Quotients of Logarithms. Do you remember the product of powers rule from our chapter about exponents? To multiply powers with the same base, add the exponents. Because logarithms are exponents, this rule applies to logarithms. And here is the rule. The log of this product is equal to the sum of these logs. Logarithms are really exponents, so this is showing how you add together these two logarithms when you have a product. Do you remember the quotient of powers rule? To divide powers with the same base, subtract the exponents. And here is that rule applied to logarithms. The log of this quotient is equal to this difference of logarithms. How do you use those rules to do anything? Well, here's some examples. Let's solve this equation. On the left side of the equals, we have two logarithms. They have the same base. They're both common logarithms with base 10. And we have a sum. So we can apply the first rule from today and condense this to a single logarithm by multiplying together the two arguments of the logarithm. And that's equal to 1. That simplifies our equation and makes it easier to solve. Now we can convert the logarithm equation into a corresponding exponential. The base of a common log is 10, so 10 to the first power is equal to 5x. Therefore, x is equal to 2. In our second example, we have a logarithm equation, and the base is the same each time, base 5. So let's apply the rule that allows us to condense to a single logarithm expression. Notice our logarithm is base 5. When there is subtraction, the corresponding rule is to create a division expression, and that's equal to 2. We still have log base 5. There's still the x to the third power. There's still the x. It's the subtraction that has changed into division. To solve this logarithm equation, make the corresponding exponential function. The base of 5 raised to the second power is equal to the x cubed over x. This makes 25 equals x squared. Therefore, x equals positive or negative 5. When we check our two answers into the original equation, we find out that we can keep the positive answer, but we can't use the negative answer. For example, look right here. The base 5 log of negative 5 is undefined. Remember when we graphed our logarithm functions, the graphs didn't exist with negative x values. There was a vertical asymptote at the y-axis, and the graph existed to the right of that. That meant we could not find logarithms of negative values. Next example, we have an equation. Maybe this equation comes from some sort of science problem. And now we want to solve the equation for a. We need to condense it. We write log base 3 of 2a minus 5 over a squared plus 4a plus 4. And that's equal to negative 2. Whenever we're combining logarithms into a single logarithm expression, called that condensing, a minus sign changes into division. Now let's write this logarithm expression in its corresponding exponential form. Take the base, raise it to the negative 2 power, and that's equal to the argument of the logarithm. So the 2a minus 5 over the a squared plus 4a plus 4. Three to the negative 2 power is 1/9. And that's equal to 2a minus 5 over a squared plus 4a plus 4. Now we need to solve this equation, which is set up like a proportion. One way to do it is cross multiplication. So 1 times a squared plus 4a plus 4 is equal to, and then 9 times 2a minus 5. Let's distribute that 9. Getting 18a minus 45. This is a quadratic equation, so let's get it equal to 0 on the right side. A squared minus 14a plus 49 is equal to 0. This trinomial is a perfect square trinomial. It factors as a minus 7 squared. Then take the square root of both sides. Getting a minus 7 equals the square root of 0, which is just 0. And now add 7 to both sides, getting a equals 7. So with a little bit of work, we finally got the value of a. Let's summarize this lesson. When we have equations that have multiple logarithm expressions in them, we need to have a way to condense the equation into a simpler form. To do that, we apply the exponent rules. When two logarithms are added together, we can rewrite using a single logarithm and the product of the two expressions. When two logarithms are subtracted together, we can rewrite using a single logarithm and using division between the two expressions.